All right, we're continuing on here in our geometry unit. We talked about triangles in our last topic, and so now we're going to move on to other polygons. What's a polygon? Well, polygon is a simple closed figure formed by three or more line segments called sides that intersect only at endpoints. They do not overlap. So, closed figure, all the sides are straight, no intersections, no overlapping lines. So these figures in blue are all polygons, all straight lines. They're enclosed and no overlapping lines. These are not polygons. This one has a curve, making it not a polygon. This one has an overlapping line, right? An intersection like that, not a polygon. And this one is not closed. The sides don't connect. Okay, so you need to be able to name polygons, which you've probably been doing for years here, based on the number of sides. That's how they are named. So these should all be familiar to you. Triangle, quadrilateral, four sides, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. These are ones you are supposed to know. In your book, this is addressed on page 513. They do the same discussion we just had there. What's a polygon, what's not, and how do you name them? So your questions here are, determine if this figure is a polygon, and if it is, what is it? Classify the polygon. And if it's not a polygon, say why. So this one is a polygon. It has all straight lines and a closed figure, and it has 1, 2, 3, 4, 5, 6, 7 sides, making it a heptagon. All right, so got it. 1A here. Polygon, yes or no? The answer is yes. It is. Closed figure with all straight sides, no intersections. And what kind of polygon is it? How many sides are there? 1, 2, 3, 4, 5, 6. 6 sides, making it a hexagon. 1B, polygon, yes or no? The answer is no. Curved. Polygons must have straight lines, and this has a curved line. All right. Well, like we talked in the last lesson about the interior angles of a triangle, you can also, there's a rule here about the interior angles of any polygon. Okay, and the answer is that the sum of the degree measures of the interior angles of any polygon with n sides, n is the number of sides of the polygon, is n minus 2 times 180. Right, so you can kind of remember this, that a triangle has 3 sides, and 3 minus 2 is 1. 1 times 180, a triangle has angles that add up to 180 degrees. A quadrilateral, 4 sides. Okay, and part of what they talk about here is that you can draw diagonals in a polygon. Okay, and diagonals go from non-consecutive vertices, right? So any two vertices, the corners where the line segments come together, that are not next to each other, right? Not adjacent. So a quadrilateral can be split into 2 triangles by a diagonal. A pentagon is split into 3 triangles. Hexagon can be split into 4 triangles because of the way the diagonals can go from one vertex. Okay, so the number of triangles of the shape is 2 less than the number of sides, and this is how you can kind of get to the fact that the interior angles of any polygon add up to degrees equal to n minus 2 times 180. So if I give you a shape, you should be able to say how many sides there are, or what the interior angles add up to. Like this example, okay, what is the sum of the interior angles of a nonagon? A nonagon has 9 sides, n minus 2 is 7. 7 times 180 is 1,260. So the interior angles of a nonagon add up to 1,260 degrees. Okay, how about a 13agon? which has a name which I don't actually know. We'll talk about that at the end here. What do the interior angles of a 13agon add up to? N minus 2 is 11. N minus 2 times 180 equals 1,980 degrees. 2b, what are the interior angles of an 18agon add up to? That's an 18-sided polygon. N minus 2 is 16. 16 times 180, 2,880 degrees. And obviously you can use a calculator for all these. Have a calculator for test and quiz. Okay, now the most common shapes that you think about when you think about polygons are the regular polygons. A regular polygon is any polygon that has all congruent sides and all congruent angles. Okay, all the sides are the same length and all the angles are the same measurement. Okay, a regular polygon is equilateral, meaning all the sides are the same length, and equiangular. All of the angles have the same measurement. So an equilateral triangle, which we talked about in their triangle lesson, 3 equal sides and 3 equal angles that are all 60 degrees. Okay, so we could mark all of these regular polygons with tick marks that they all would have the same length, right? This regular polygon. A regular quadrilateral, a 4-sided figure with all sides the same length and all angles equal, is called a square, more commonly known as a square. What are the interior angles? What is each angle? Okay, so to find the interior angle, what each interior angle is, you'll find the sum using the rule of n minus 2 times 180, right? And then divide by the number of sides, which is n. So n minus 2 times 180 divided by n basically is how you would get the measure of each angle. So square, you probably already know that the angles of a square are 360 divided by 4. Okay, 360 is 4 minus 2, which is 2 times 180 divided by 4, 90 degrees. Okay, the 5-sided shape is a pentagon. And what are the interior angles of a regular pentagon? Well, the sides add up to 5 minus 2 times 180, or 3 times 180, and then divide that by the number of angles that there are, which is 5. So that comes out to 108 degrees. 6-sided polygon, that's called a hexagon. 6 minus 2 times 180, 4 times 180, divided by 6, because there's 6 angles in the hexagon. So that's really 30 times 4, right? 180 divided by 6 is easy to do in your head. That's 30 times 4, 120 degrees. So each of these angles in this regular hexagon would be 120 degrees. Okay, and they would all be shown by the same number of arc marks if we wanted to show that all these angles are equal. Because it's regular. That's what regular means. And lastly, the 8-sided polygon called an octagon. 6 times 180 divided by 8, right? 6 times 180 is the sum of the interior angles, and then divide that by how many angles there are. They're all equal, 135 degrees. So this is also something you should be able to do. All right, so that's it. Here's some practice problems in the book, some guided practice. Is it a polygon or not? If it is, then classify it. What is it called? And if it is not a polygon, explain why it is not. Number 1, not a polygon because it is not closed. Not closed, not no closed, not closed, right? It doesn't, there's an opening between the sides. Number 2, polygon? Yes. And what kind of polygon is it? It is not a star. Right? That's not one of our names. How many straight sides are there on this thing? There are 8. Therefore, it is an octagon. And number 3, polygon. Yep, that is pretty much a regular, it looks pretty regular, a regular pentagon. You don't know that it's regular because there's no markings on there. If we wanted to confirm that it was regular, you would actually have to mark all the sides the same length with tick marks and all the angles the same with arc marks. Okay, if you wanted to actually show that it was regular. But it's certainly a pentagon. All right, here's a good problem, kind of twisting the formula there. The sum of the interior angles of a pentagon, a regular polygon rather, the sum of the measures of the interior angles of a certain polygon is 1,800 degrees, 1,800 degrees. Doesn't have to be regular. How many sides does this polygon have? Okay, well, we know the total amount, and we can then just solve the equation for n, right? So 1,800, the sum is 180 times n minus 2. There are 2 ways to solve this equation. We didn't really talk about the first way, but you might just see it right away. It's certainly easier. The arithmetic's easier. And that would be by dividing both sides here by 180, right? So divide by 180, that means n minus 2 equals 10. So if n minus 2 is 10, then add 2 to both sides, and n equals 12. So that's one way to do it. Or you could solve this original equation using the distributive property, kind of like we did it when we were working in the map in the last unit. 1,800 equals 180. That's the rainbow, right? So 180n minus 360, 2 times 180. And you can add 360 to both sides. You get 2,160 and divide that by 180 and also equals 12. So either way, you could solve that. And the answer is that it is a 12-sided polygon, which is called a dodecagon. Dodecagon. All right, polygon or not? If it is, what is it? If it is not a polygon, why not? Number 8, yes, pentagon. Number 9, yes, 8 sides on this one, octagon. Number 10, yes, 6 sides, hexagon. Number 11, no, because it has intersecting sides, okay? Anytime you have 2 lines crossing over each other like that, not a polygon. Number 12, this is kind of a strange looking shape. Is it a polygon? Yes, it is. How many sides does it have? 9 sides, making it a nonagon. That's what I got anyway. 2, 3, 4, 5, 6, 7, 8. Yep, 9 sides. And number 13, polygon. No, this is all curved. It's actually a circle, not a polygon. All right, and what is the sum? What is the sum of the interior angles of a decagon? What do the angles of a decagon add up to? There are 10 of them, meaning n minus 2 is 10 minus 2, which is 8. 8 times 180, 1,440 degrees. How about an 11agon? Unanagon, I think, is one name for it. There's another name for it, which we'll talk about in a second. And the number of sides is 11. So 11 minus 2 is 9. And 9 times 180 is 1,620 degrees. So an 11-sided polygon, the angles add up to 1,620 degrees. That's pretty much it. Oh, one more problem out of the practice problems in the book. We talked briefly about exterior angles with triangles in the previous lesson. These are the exterior angles of a pentagon. Okay, so you extend each side in one direction, you get a bunch of exterior angles, same number as interior angles. Okay, well, it turns out that the sum of the measures of the exterior angles, one at each vertex, is always 360 degrees for any polygon. So for each of these regular polygons, what is the measure then of an exterior angle? They add up to 360 degrees. So for each of these, all you basically have to do is divide 360 degrees by the number of sides. So an octagon has exterior angles of 45 degrees. A triangle, exterior angles of a triangle, they're supplementary with the interior angles of the triangle, and so they all add up to 360 divided by 3, or 120 degrees each one. Decagon, 10 sides, 10 angles, 36 degrees. And the 15agon, divide 360 by 15, 24 degrees. So these are the they're exterior angles that you can make from a polygon. And they all add up to 360. You do not have to remember that. Okay, so the things you need to be able to do from this lesson: be able to know whether a shape is a polygon or not, name the polygons up through decagon, okay? And also understand the interior angle sum of polygons is 180 times n minus 2. This is a good website. Here, Math is Fun. Their discussion of polygons is pretty interesting. They go through the same things. Now, they do talk about complex polygons. So they'll talk about simple polygons, which is really the ones that we're talking about. They have, of course, the discussion of regular polygons, all sides and angles equal. Otherwise, it's an irregular polygon. Kind of makes sense. Polygons can be concave or convex. You don't have to know that, but concave means that it has kind of an internal piece to it, okay? If any internal angle is greater than 180, it's concave. Here's the simple and complex. We don't call these polygons. The textbook doesn't. The 8th grade textbook doesn't. So they call it a complex polygon when it has intersections like that, but we don't need to worry about that part. Okay, then I have this cute little interactive thing where you can take any shape, right, that you can add to the sides by these arrows here. Like take a hexagon, and then you can drag the points around, and it says, oh, that's a concave hexagon. Okay, or you can, make it whatever you want, any kinds of strange shapes, or you can change it to automatically to a regular hexagon, okay, and expand that around a little bit. You can look at what the angle measurements are. You can look at the lengths of the sides. You can make it bigger. All the sides are the same length. You could get the coordinates of each point. Really kind of complicated. Drawing all the diagonals. Okay, so just a little interactive, applet here that you can mess around with, which is kind of cool. And the other thing is it has a list of what polygon names are. Okay, so it starts with the normal ones that we just talked about. A triangle, which is actually also called a trigon. A quadrilateral, which can also be called a tetragon. Pentagon, hexagon, heptagon, octagon, nonagon, also known as an enneagon, and a decagon, 10. Well, then it goes past there. It also tells you what each, for a regular one, if it's regular, what the shape looks like and what the interior angles are, like we talked about in that one question. But this goes on to 11, 12, up through 20, and then 30, 40, 50. Okay, so that if you were wondering, what's a 14-sided polygon called? It's a tetrachidecagon, okay? Or a hexachidecagon has 16 sides, okay? And an icosagon, 20 sides. Tetracontagon, triacontagon, heptacontagon, okay? And then you can go even more to 1,000 sides, the chilagon, never knew that one, 10,000 sides. And then it goes through a little we can talk about an n-gon. The n-gon has n sides, right? And then they also go how this naming works. So this is just kind of interesting if you're if you're at all interested in this stuff, right? And it goes through some ways to remember these things too, like the pentagon. Okay, so that's it. And we will talk more about these in the next class. We'll just kind of do a quick review. Polygons.